Okay, now when you put new pipes out of your system, periodically as you build new stuff and replacing things, you're gonna have to put new pipes out there in your system. In order to help prevent any kind of contamination, loss of connection, or anything, we have minimum distances. Here in Louisiana, I understand it is 6 feet horizontal, 18 feet 18 inches vertical. Is that correct? Well, the purpose of that is in case you have a leak on, say, a sewer line or something, you don't have that sewer line leaking in and get into your water line. Because the odds are that sewer line leaks, it's not under pressure. Most sewer lines are gravity fed. They're gonna drip down and go locally. But what happens if you got that water line running parallel underneath that sewer line? First time you lose pressure, you get down to that 15 or below. You siphon that stuff right in there, and next thing you know, you've got an outbreak of something. You're putting out a boil water notice. You've lost all confidence in your customers have lost all confidence in you. Well, keeping the lines separated will help prevent that. Now, what we do is we recommend that you have at least 6 feet horizontal, 18 inch, and if you do have to go across each other, your water line should always go off the top. A big part of working with putting in the lines is you're going to have to deal with trenches. We'll go a little bit of the trench requirements in a minute. Also, your cover material. You want to make sure you put in good, clean cover material in, not necessarily the stuff you pulled out. You might have to put in fresh cover material so you have at least a 24-inch cover over your pipe. The purpose of that is that way you don't have a pipe accident get hit with something, help minimize the loads that are on it from anything passing over the top. Now, I understand that there's some situations you're dealing with what's already out there. I know there's a lot of instances I've seen out there where that line might have been 24 inches or lower when it was put in, but the ground was eroded over time, things have washed away, now all of a sudden you got this pipe that's only 6 inches underground. Somebody digging with a shovel hits it and finds it. Or worse, somebody digging with a backhoe hits it and finds it. Trench safety is a big issue. I don't remember the exact statistics, but there's a lot of people killed every year in trenches. It's one of the most dangerous aspects of our job. That and confined space injuries are the two ones that kill a lot of people in the water business. OSHA regulation says anything greater than 5 feet must have some type of shoring or trench, some sort of trench protection, something to keep it from caving in. Now, some states, I'm not sure if Louisiana, do y'all apply the 5 foot or do you go 4 foot? Okay. 5 feet? All right, I got a confirmation back there in the back. He looks confident. Exactly. Yes. 5 foot is a general one-size-fits-all regulation, but you also have to look at your individual situation. Like I said, under OSHA, OSHA is a minimum requirement. Your state can set stricter, just like with EPA standards, they can set stricter standards and be more stringent than the federal regulations. A lot of states have gone to anything over 4 foot, regardless of the type of material, you have to provide some sort of caving protection. Like I said, shoring is basically anything used to support the walls of that trench, that way they don't cave in while you're down there working. In some situations, you may get away with sloping, which sounds pretty self-explanatory. It's basically, you build your wall, you dig your walls out at an angle, that way there's less chance of them caving in on them. Now, sloping is easier in some situations where you don't want to have to build shoring, you don't have a trench box available. But the drawback to shoring, you usually have to dig a lot wider hole. And for most situations, especially if you're doing a repair or something, you're in an area where things are already built, you don't have the luxury of digging a 12-foot wide hole to meet those sloping requirements. anything you dig out of that hole, any dirt you bring out of that hole, anything you bring out of there is a spoil. Any spoil you bring out of that hole needs to be at least 2 feet away from the edge of the hole. And if it's a real flowable soil or anything that's likely to slide, recommend you put it back further than 2 feet. But 2 feet is the minimum. All right, now once you dig out that hole and you put the pipe in there, you know, we're going to just lay it in the hole on whatever down there to start with. That may be what happens a lot of times, but that's not what you should be doing. You should go back in with some good, clean bedding, minimum 4 inches. That way you have some control over what's down there. Most places use a stabilized sand, which when it goes in, you know, it's easy to spread, but once it gets wet, it hardens up like rock, provides a nice solid foundation for that pipe, reduces the chance of it moving, bending, coming apart. Like I said, once you put the pipe, you put your bedding in, put your pipe in, then and only then you backfill it. And make sure whenever you do your bedding, you tap down that bedding material. So a lot of times people will put that dirt in or they'll put that sand in. Well, once that pipe gets in there and it starts settling, you end up uneven pipe, you know, creates stress on your joints, increase your odds of something breaking. Like I said, up here we got a few pictures of, you know, the correct way to do your bedding. Like I said, your bedding should fill in any gaps underneath that pipe. It should be a nice, smooth, even foundation for that pipe to sit on. You know, if you get something like that very bottom where you have a high point in the middle, now you got a stress point on each end of that pipe. You know, any shift to the ground, somebody drives a truck over anything, you're going to be back out there repairing that pipe again. Anytime you have any type of a bend in your pipe, as water moves through the pipe, it exerts a lot of pressure. Especially anytime it comes to a dead end or a sharp turn or any kind of a curve, anywhere where that water's coming against some resistance, it's going to push back against that pipe. So anytime you have a T, a 90, anything, it's really important to make sure you go back in with some sort of blocking, some sort of bracing. This bracing can take the form of, I've seen steel pylons driven in behind it. I've seen wood. It's not usually recommended because that wood doesn't hold up over time. It may work temporarily if you're doing a temporary fix, but for long term, steel or most commonly concrete. You know, not only is it important to put these in, but if you're ever out there working and you have to do an excavation, it's important to be conscious of these vacuums, these braces. We had a situation a few years back. We actually had a contractor killed. They were working on a 36-inch pipe. They dug out a thrust block so they could go in and weld up a joint. Well, after they got done welding, they wanted to make sure that the fresh weld held. So they had the welder stay down the hole, brought the line on to check for leaks. Well, when that water hit that curve where he just made his weld, the pipe blew apart. I don't care who you are, how fast you are, you're not getting out of the way of that 30-inch pipe when it comes apart. I said, unfortunately for him, he didn't make it home that day. All because they didn't take, well, they violated multiple rules, but the one that really got him was the fact they dug out that thrust block and turned that line on with nothing to hold it in place. Now, I'm going to tell you the ideal stuff, and we know that we live in the real world. It's not always possible, but anytime you're laying pipe, doing repair, you know, that trench should be nice, clean, and dry, right? That's the way they all are. They never get any water, mud, anything like that. Well, like I said, ideally, you should keep it as clean and dry as possible to help prevent any contamination from getting back in that pipe. But we all know that you can't do it. It can't be done 100% of the time, and you're not going to be able to keep everything out. But make a concerted effort to keep as much of it out as possible. It's a lot easier to keep that stuff out of the pipe than it is to get it out of the pipe once it gets in. swab everything you put in with a hypochlorite solution. What I tell my contractors is, take a 1 gallon bottle of household bleach, put it in a 5 gallon bucket, top it off with water. Get you some clean rags, wipe everything you put in that, everything that's going to come in contact with water, wipe it down with that clean rag. Now, at the end of the day, or any time maybe you're going to take a break, go to lunch, cover up the end of that pipe. Because I worked in the distribution system for many years. I saw, you name it, I've probably seen it come out of a pipe or in a pipe. I was once on a crew that we inspected large diameter lines when they would take them out of service. We would actually walk through the pipes. I've seen everything from buckets, hard hats, gloves. Found some bicycle parts in one. I still haven't figured out how those guys do it. You know, so at the end of the day, something as simple as taking some plastic, duct taping it over the hole. Ideally, you would put a pipe cap, but at least, at the very least, put some kind of plastic that will keep animals and stuff out of the pipe. Because I've seen, you know, many a dead animal come out of pipes too. I don't know about you, but I don't want to drink dead squirrel water, skunk water. Now, according to AWWA, any new pipe, any new piece of equipment that goes into a water system must be disinfected. Now, if you go to the AWWA standard C610-92, it'll give you all the details. Now, again, this is the federal recommendation. Your state may be stricter on the requirements, but generally the AWWA is what most states go by. They recommend 3 different methods: tablet, or as most people call it, HGH. Throw some granular pool tablets in the thing. But if you already do that, from personal experience, I recommend do not use the tablets. If you're going to use HGH, put the powder in there. Those tablets, I've seen them get lodged in fire hydrants and line up being serviced a year. Go out there and flush that hydrant, and it's still got a chunk of HGH stuck in there. Continuous. That is where you basically set up just like you would in a plant. You put a gas or liquid chlorine feed system, and you continuously add chlorine as the water flows through that pipe, and you get the desired residual at the end of it. Now, this is what we use in Houston. You know, for a smaller system where you're not doing, you know, a lot of new construction, it may not be practical for you to build a system to be able to do that. We do about 100,000 feet of pipe a month, so it was cost effective for us to build a system to actually take out rather than using the HDH. Slug. This is what you do if you have an emergency situation. Say you put in a new 100 feet of pipe for some kind of emergency. This pipe's got to go in service right away, but you still want to make sure that it's safe. You dose it up a lot higher than you normally would put it. AWA recommends 300 parts per million residual for the slug. You dose it up to 300 parts, 30 minutes, flush it out, take your sample, put it in service immediately. Whereas on the continuous or the tablet, you generally put about a 25 part residual, leave it in there for a 24-hour contact time. After 24 hours, you have to have, I believe it's, again, this is for Texas, I believe Louisiana's the same, you have to have at least a 10 part residual after 24 hours. Once you flush that out, you bring it down to normal residual, take your samples, you get good samples, you can put that line in service. And if you want specific details on that, they're available in table 7.1. I said, after you disinfect, you dose it up to the 25 parts. You obviously don't want to put that into a customer's house. So make sure you flush it. Again, most states have gone to now requiring you dechlorinate and highly chlorinate the water you put in there. Some states are still very ambiguous on their requirements. One of the issues we had was the requirement said it must be less than 4 part residual before it reached a receiving stream. But we had questions for it. Define a receiving stream. It's not in the regulations. So, say it. Okay, it is defined here? Okay. Well, ours wasn't defined until just recently. As of, I think it was September 1st this year, we now have employment also. And it's a good idea anyway. It's, even if it's not a practice, if it's not a regulation, it's a good practice. Because obviously, if you're pumping out 20 parts per million of chlorine and you're going directly into a bio, you're potentially causing a problem for yourself. You can have a fish kill. You can upset that bio. Sometimes it's easier to buy a little dechlor and dechlorinate that and save yourself the headache. I said, once you get the sample, once you get your line flushed out, you're going to collect a back T sample. These are the same back T samples that you can take on your distribution system. It basically follows the same practice. You have to refer to your state's guideline for how many samples are required, locations. For Texas, we have to have 2 consecutive samples for every 1,000 feet or every dead end. Does anybody know what the regulation here is? Anybody collected samples out there? Supposed to. So that means, yes, of course. All right, in order to maintain your distribution system, one of the things you need to do is periodically flush all your dead ends in your system. Again, this may be, I believe this is a state mandate here that you flush all your dead ends once a month. Basically what you're doing there, you're opening up your fire hydrant, your blow off, whatever you have at the end of that line, and you're flushing, making sure you've got good chlorine residual, good water quality, flushing. One of the big things there is once you open that line up, if you do have a problem such as rusted water, do not shut that line off until you clear it out. Because once you've stirred it up, if you don't flush it out, you'll be right back out there answering customer complaints. The purpose of it is to help reduce slime, scale buildup, eliminate rusted water, increase your chlorine residuals. Because a lot of times your chlorine residual, if you have an area where there's just not that much usage, you've got more supply going in than going out, that water may sit in that line for a long time. Chlorine's a natural product, so it'll gradually deteriorate over time. By sometimes going out there, flushing that hydrant for a few minutes, get that residual back up, get your good quality water going back to your customer. Also, a lot of times you get a biofilm build up in your pipe, organic materials that will eat up that chlorine. Sometimes flushing will be enough to scour that stuff out, move it out of the line, and not only get that residual up for that day, but you get where you'll be able to keep that residual up. Always make sure that you're aware of your surroundings whenever you go through these fire hydrants. Remember, they put out a lot of water, a lot of force, and water being a universal solvent. It will solvent. It will dissolve soil. It will wash away plants. I had an employee damage someone's car opening a fire hydrant, and their attitude was, well, they shouldn't have parked in front of the fire hydrant. Two wrongs don't make a right, because now I got to explain why you damaged somebody's car. So just be very, be aware of your surroundings whenever you're opening that fire hydrant. Remember, and not only what's immediately around it, look around, see where that water's draining. Especially if you're in an area where you have open ditches, just because it's draining from where you're at, drive around the corner. Make sure that you're not flooding the guy around the corner's house because the drainage from his house is where it stops. And this is just a picture of why we need to flush. And this is an example of a fire hydrant. All right, scale of tuberculation. That picture on the left is an example of scale, which is basically a buildup of oxidization inside the pipe. If you have a house built probably in the 60s or 70s, you've got galvanized pipes in your house, and I guarantee if you ever replaced them, they look about like that. I personally pulled all the piping out of my house, and I was down maybe less than a pencil-sized stream making it through all the tuberculation. I wondered why I was having to put a repair clamp on water line in my attic about once a week. I finally got off my butt and climbed up in the attic and replaced it. Now, the other problem you might deal with on pipe is corrosion. Corrosion is different than tuberculation. Whereas tuberculation is a buildup of material, your corrosion is a dissolving of material. It's a similar principle, but instead of building up in your pipe, you're eating away at your pipe. Just think of something rusting away. I said this can be a major source of customer complaints for you. Usually your red water complaints mean you have old cast iron pipe that's starting to rust, which is a form of corrosion, and is getting to the customers. There's a lot of different things that will cause corrosion: low pH, dissolved oxygen, salts, too much chlorine in the water, hardness issues, even high velocity. Like I said, water being that universal solvent, as it's flowing through that pipe, really high velocities. What happens if you take a water hose and you squirt it at a pile of dirt? It erodes away. Same things happen inside the pipes. Temperature, alkalinity. This is supposed to say sulfate reducing bacteria. Now, how do you prevent the corrosion? You can do many ways, including putting protective coatings, linings. In your smaller pipes, that might be something like having galvanized pipes, which when they're new, they work great, but they do corrode or they tuberculate over time. Or even paints. Again, as long as they are NSF-approved paints, you can put them on the inside of the pipes. Anodes, that's a form of cathodic protection. Everybody here familiar with cathodic protection? Know what that is? Basically what it is it's got to do with the electrons and the charges of the tank. Now, the metal naturally wants to deteriorate. Now, you can do certain things like the anodes, they can be a sacrificial anode, which is basically you take a material that is easier to corrode than your pipe. This is what they put in hot water heaters. You'll take they call it sacrificial anode because you put it in there and you want that to corrode. You want all those agents that are causing corrosion to attack that rather than attack your pipe. Now, the only issue with those is they're not, they do not have an unlimited lifetime. You do have to go out there and check them and make sure that there's still something there to provide the protection. A lot of times they're put in the ground and buried and never thought about it again until the line blows apart and they hear, well, we spent all that money on these anodes, didn't they solve it? Well, not if you don't ever follow up with it. Exactly.
Does anybody use gas to use DC voltage?
Yes, actually, City of Houston, we do use that on some of our very large diameter stuff. That can be very cost prohibitive for most situations. It's expensive. It requires monitoring. It requires a little more labor intensive, maintenance intensive, but it does work very well. They basically put a small electrical charge on it to reduce the amount of corrosion. Like I said, we use that for very large diameter lines, 48-inch, 60-inch lines, things like that. Things where it would be catastrophic if they blow out. Another cause of corrosion is an interaction between different types of metals. Certain types of metals, when you put them together, it creates a chemical reaction which will cause your pipes or the material to corrode very quickly. Usually, you'll see this a lot of times, like, again, going back to hot water heaters. You'll have somebody replace a hose on a hot water heater or something. They go out and they find something that's available. They find a galvanized, nipple to replace the one that went out. Well, they don't realize now they're connecting galvanized steel to copper. Well, guaranteed within a year, you're going to be out there because that galvanized nipple is leaking again because you've got just similar metals interacting together to create corrosion. Whenever that happens, that's referred to as galvanic corrosion. Also, there's certain types of chemicals you can add to your water to help reduce corrosion in your system. A few years back, we had sold by a salesman a particular phosphate that he swore up and down would eliminate all our corrosion problems in our system. Didn't work as well as we anticipated. I mean, there are good chemicals you can put in there, but again, usually it's cost prohibitive. And plus, we don't want to add any more chemicals to the water than we have to. Anytime you do have two different types of metals where you have to connect them together, there's special fittings called dielectric unions that you can put in there, that they're made to interact between those separate metals. So you don't have a direct connection between the two types of dissimilar metals. Correct. They will still corrode, but it'll slow it way down. Yeah. I mean, there's nothing out there you can put out there that's going to prevent the corrosion completely. Your biggest goal is to slow it down. Keep it from, if you can stretch that pipe from lasting 5 years to lasting 10 years by putting that diode in there, it's well worth it. Now, another problem you're going to deal with a lot is your main brakes. I know it's particularly for smaller systems. As an operator, you have to do everything. You handle everything from reading the meter to making the repair to running the plant. Well, a lot of times, particularly with smaller systems, you may have issues with not having the necessary equipment. What a lot of systems are going to, and I believe you'll have a lot of this here, is like a cooperative system where maybe several of your small systems get together. That way you can buy some of the more expensive equipment you need. That way you have the specialized equipment, sometimes not even necessarily specialized equipment, but more expensive equipment like a backhoe that you might need periodically to do those repairs. When you do have to make a repair, you want to make sure you can excavate down below the pipe on both sides. That way you can get a clear view of what's actually going on there. Because just because you dig down and you find water coming out of the top, doesn't necessarily mean that's where it's originated from. Going back to the sanitation issue, in order to make sure that you're minimizing any contamination in there, dig a sump on one side of that pipe. That way you can drop some sort of a pump in there, something to keep that hole from filling up while you're working. Now, this isn't popular with the guys doing the repairs, but it's recommended that you repair the line hot whenever possible. Now, what do I mean by repair it hot? It basically means leave the water running while you're doing the repair. And you say, well, that seems counterintuitive. I want to stop the water so I can see what I'm doing. Keep that water out of the trench you keep talking about. Well, a few different things. It helps prevent having to shut the water off for the customer, interrupting their service. Because just because a line's leaking doesn't mean it's not still getting the water to the customer. They may have lower pressure, but at least they've still got some water. You're not having to shut somebody's water off in the middle of their shower or something. Also, as long as you have a positive pressure on that line, it reduces the potential of cross connection, anything getting siphoned back into that line. To me, that's probably the most important reason. It protects the integrity of that line. As long as you've got a positive outflow, even if it's leaking significantly, as long as the water's flowing out, it's no hard for anything to swim upstream and get back into that pipe. It reduces that error the main we talked about earlier. Cross connection. Who knows what a cross connection is? Should know this, everybody, we talked about it earlier today.
Water, not water.
Correct. It's any connection between a potable water source and a source that is either unknown, lesser treated, or a known hazard. Some of your examples of cross connections would be somebody hooking up a water hose to a pump to prime it. You know, especially say you're in a wastewater plant, you need to prime your pump. So when you do, you grab the water hose, you hook it up to the priming port on there, and you fire up that pump. Next thing you know, you push that sludge right back into your drinking water. You can ignore where it says TCU requirements. These shouldn't be the standards for all states, though. Most places, you have a choice. The most effective is an air gap. An air gap is just what it sounds like. A physical separation between the 2 points. For Louisiana, I believe it's a minimum 2 inch, but as a rule of thumb, it is 2 times the diameter of the pipe with a minimum of 2 inch. Half. Two times the diameter of the pipe, or a minimum of 2 inches. That way, if you have any sort of backup, that water can't force its way back up through the air. When that's not possible, you can put in backflow prevention devices. But a big problem with backflow prevention devices is, it's like everything else, they require maintenance. When they're brand new, they work great. Once you put them in there, you forget about them. 5 years down the road, suddenly nobody looked at it. You know, somebody new has bought the company. You know, the backflow preventer's sitting behind a stack of boxes. They don't even know it's there. It's supposed to be tested or is tested every year. That's usually a big problem for systems of all sizes. It's usually a manpower issue of actually going out and inspecting them.
No, you're required to have a plumber come out, somebody that is state certified to come out and test those backflow devices. And they're supposed to be turned that in annually to wherever they get their water from. And you're supposed to have a backflow prevention plan in place. And it's actually, we actually have an ordinance for it, I know the city of Pineville does. And you know, they have to send it in to you to let you know that it's not, if they don't, we go out and test it, so it's twice as much as what a plumber charge.
I mean, that's great. I mean, that's the way it should be. But a lot of times, you know, even if you have an ordinance like that, it's a matter of enforcement. You know, usually a lot of places, it's very labor intensive. Just think about how many connections you have and how many backflow preventers each one of those connections might have. Again, going back to my day job, City of Houston, we have 22,000 identified high-risk connections. We have so many of those, we can't even attempt to look at household stuff. We can't even keep up with the stuff we know is high risk. And you know, that's a problem for systems of all sizes. You know, really big systems, you may have so many connections, you just can't keep up with it. Your small systems, again, you've got that 1 or 2 operators, they're responsible for everything. They just don't have the manpower to do it. But ideally, yes, they should be inspected yearly. And if the program is run correctly, it will, you know, it's a major improvement for your system. It really goes a long way in protecting your customers. And a big part of that is educating the customers of why they should do this. Explain to them that this isn't just another regulation. We're not making any money off this. We're not trying to ensure the plumbers have plenty of work by inspecting their stuff. We're doing this to protect your public health. Some of them will still say, screw you, I don't want to spend the money. Now, what do we do when we have an emergency? We never have emergencies in the water business. Everything goes as planned every day. But shaking your head, you mean things don't go smoothly every day? Well, you know, emergencies can take all types of forms. That could be everything from a pump breaking down, a well blowing out of the ground, you know, a tank failing, chlorine leak, you know, anything. Now, the biggest thing, well, one of the major things you need to do is make sure you have repair manuals for the equipment you have on hand. I can't count the number of times I've seen an emergency, a pump breaks down, and you have to call somebody in. Nobody knows where the repair manuals are. Hopefully, you know, as stuff is put in, as things are built, you're getting an operator manual on it, you're getting a repair manual, you're putting them somewhere where they know. It's important to make sure that it's not just up here in the maintenance guy's head. He knows how to fix that pump. What happens if he's not there that day? What if he retires? He's out sick. He's the cause of the emergency. You know, what are you going to have to do if you bring somebody else in? You want to make sure you have these manuals available. And again, this comes back down to the budget issue, and a lot of times people just can't afford to have a bunch of spare parts sitting on hand. Especially when you've got a piecemeal system where you may have 5 different brands of pumps, so you can't keep a spare packing lane for each one of those pumps on the shelf. Identify the parts you know are most likely to fail, the ones that are hard to get, things that have long lead times. If you know that the bearings on your booster pump takes 6 months to get, try to have a set sitting on the shelf. I know a lot of times it's easier said than done because you're having to ask, you have to allocate money, you have to ask people that don't actually have to do the repair to fund this stuff. But it can save everybody a lot of headaches in the long run. And what do you do when you have a major emergency, like a hurricane, tornado? Do you not have tornadoes here? No, we're most concerned about hurricanes. We do have tornadoes. Hurricanes, they just scare us. Now, you know you have an emergency, especially, unfortunately, with things like a tornado, you can plan, but you don't have time to prepare necessarily. Because when it happens, it just happens. You know, hurricane, you get a few days' notice to get things together. But in general, for any type of emergency, make sure you have some sort of a plan in place. Let your people know what their roles are. You know, don't wait until the day of the hurricane hitting to decide who's going to stay, who's going to evacuate, you know, who's going to be stationed at what facility, who's going to be responsible to get key pieces of equipment back up. Have a plan, discuss it with people, practice it. Don't write a plan, put it on a shelf, and 5 years down the road, when that hurricane finally hits, everybody's running around, where's the emergency plan? Well, Burley wrote it, maybe it's in his office. Burley retired 3 years ago and took it with him. You know, make sure you fill up all your tanks, you know, top off the gas in your vehicles, make sure you have plenty of repair parts, things like repair clamps, hypochlorite, things you might need to do to get pieces of equipment back in. Quick repairs in short order to get things back up and running. Like I said, make sure you review the plan periodically. You know, once or twice a year, you know, do a drill, run through the plan. You know, call a meeting, have a tailgate, have people come in and know, okay, this is your role, this is what you're responsible for, this is where you're going to work, these are the people who are going to have to evacuate. You know, back when Hurricane Rita was supposed to hit Houston a few years back, that's when we found out how unprepared we were. We were all sitting around the day before the hurricane was to hit, asking. This was right after Katrina, so everybody was ready to evacuate. Everybody was panicked, they wanted to leave. Workers were saying, well, I've got to go. They're telling us to evacuate. Well, you know, the system can't just shut down. Well, we didn't have a plan in place. We couldn't force people to stay. We couldn't, you know, we didn't have any way to tell people, well, you have to work.